Thank you, everyone, and welcome to STG419. Quick show of hands, who here has been to a code talk before? Anyone? All right. Who came to this session specifically because you saw that we were going to show code instead of just PowerPoint slides? Anyone? All right, that's good. Who came because it's after lunch and they're looking for a place to take a nap? All right, yeah, we'll try to keep it down for you, sir. My name's Matt Boyd, and with me is my colleague Prabir Sekri, and we are solutions architects with AWS. And today we're going to be exploring how to modernize your managed file transfers and automate your file transfer and file processing. And so, with that, let me quickly walk you through the journey that we're going to be taking you on today. We're going to start by talking about managed file transfers, what they are, why they matter, and some of the building blocks that we'll be using for our modern file transfer service that we'll be building today. Then we're going to do a quick overview of Transfer Family and its features. And then we're going to dive into our use case and a target architecture, followed by a quick sprinkling of Agentic AI, since we'll be using that as part of our solution. And then we're going to get into the code. So we will be doing hands-on coding and deployment in real time, and we'll hope that nothing breaks while we do it. All right, so let's get started. What is managed file transfer? Simply put, it is the exchange and processing of files securely, often between two known business partners or business entities, but it can also be between internal or external systems in general. And believe it or not, managed file transfer is critical to almost every industry and vertical. In finance, it is used for clearinghouse settlements, for example. In logistics, it's used for supply chain tracking. And in any analytics use case, you usually have to ingest files and content, and that is also typically done using managed file transfer at some capacity. And so for most organizations, managed file transfer is not just the process of transferring files, but it's core to their business functions and their business processes. And so with that, what many organizations need to do is they need to modernize their managed file transfer systems and move away from legacy tooling and operational overhead. And so today we're going to be showing you how to build a modern MFT system. And these are just some of the building blocks that we're going to be using today. First, we're going to be using AWS Transfer Family, fully managed service for file transfers, and I'll talk about that in a moment here. We're also going to implement some malware scanning because most organizations need to do that when they receive malware from an organization outside. And so we'll use GuardDuty malware scanning for S3 for that. Now, for the agentic workflow, or for our workflow after we receive that file to process it, we're going to remove human manual labor, and we're going to use an agentic workflow for that processing of the files that we receive. And then pulling it all together, we're going to use infrastructure as code and Terraform for our deployment and automated deployment processes, and we'll use an event-driven architecture with Amazon Event Bridge. So briefly, I want to cover the key components of the AWS Transfer Family. There's actually three main services or features within the Transfer Family portfolio. The first one is file transfer servers, and these are fully managed file transfer servers that you can deploy very quickly, and they scale automatically. They're backed by S3 storage, and they support the most industry standard protocols, SFTP, FTPS, and AS2. Now, if you need to send files to a remote SFTP server, or maybe you need to download from a remote SFTP server, Transfer Family offers SFTP connectors. And SFTP connectors are essentially a fully managed SFTP client that you can use via an API. So no infrastructure to maintain, to download or send files via SFTP to remote servers. And then finally, if you have use cases where you need to provide web-based access to files stored in S3, and you need to do it securely with authentication for human users, and in a user-friendly interface, we have Transfer Family Web Apps. This is a fully managed web app that integrates with S3, and we'll be showing that as part of the solution today as well. One other call out here is that with modern file transfers, you often want to adopt an event-driven architecture, and Transfer Family integrates with Amazon Event Bridge. So for example, you can automatically trigger downstream file processing when you receive a file. All right, so with that, I'm going to pass it over to Prabir, and he's going to talk about the use case that we're going to be building for today. And he'll show you the current state and then what we're going to be building toward.
Thank you, Matt. All right, so for today's use case, we'll be looking at modernizing a traditional insurance claims processing system. I just want to know, like, with a quick show of hands, how many of you are in like the insurance financial services domain? Okay, quite a few. Nice. And what about some other domains? Maybe you can shout it out, like what industries are you from? Healthcare. Healthcare's? Hospitality. Hospitality, perfect. So the use case I'm showing you today actually can be applied or can be seen also in other industries as well. And the way traditional insurance claims processing works is typically, it has 3 different phases, right? So typically we start with the ingest phase. This is where you will have most companies ingest files using SFTP. In our insurance use case, these could be files such as policy documents, could be images, and repair estimates. We often have an extraction phase, so this is where most organizations do have some kind of an OCR or basic OCR. And for those who don't know OCR, it's basically a technique that's used to extract text from images. And the challenge with basic OCR is that it is somewhat rigid. It only expects files and formats in a certain way. And finally, in an analysis phase, this is where you may have some kind of manual processing. You may have some intelligence with rules-based engines, but most of the times it is manually processed. And the challenge with all this approach is that not only this is error-prone, it is time-consuming, and it just doesn't scale. Now, we're going to show you how we'll transform this using cloud-native architecture. Now, here's a modern approach for this use case, which demonstrates all the principles that Matt spoke about. We'll be using secure file transfer with Transfer Family. We'll be setting up malware scanning using GuardDuty, and we will be leveraging agents, AI agents, to do the manual processing. Now, all of this architecture is going to be orchestrated using Event Bridge. And yeah, without further ado, I'm going to dive deep into each layer and we'll talk about it a little bit more. Now, our stage 1 is where we are building a secure foundation. We're going to be starting with replacing our legacy SFTP servers with Transfer Family, which means that there's no infrastructure to manage. It is fully, it offers automatic scaling and high availability. Now, we want to authenticate external users, right? These could be, especially for our use case, external partners, repair shops, and we want to do it in a secure way without managing identity. So this is where we're going to be leveraging our Transfer Family's custom identity provider toolkit. And Matt's going to do a demo on that a little bit in just a while. But by using that, you don't have to manage separate credentials. You can integrate with your partner's identity provider. It could be anywhere from Okta, from Ping, from Entra. And you want to store everything in Amazon S3 for its unlimited scalability and high durability. Now, moving on to our next stage, we want to add automatic malware protection. GuardDuty will scan every file as it arrives. It offers immediate threat detection and intelligent routing. What I mean by that is that you'll have all your clean files that are going to be automatically moved to a clean bucket, and any malicious file or a suspicious file will move to a quarantine bucket automatically, all done through event-driven architecture. And moving on, this is where we are seeing a major transformation in how organizations are processing files, or modernizing, I would say, file transfers. This is where we're going to be using AI agents to replace somewhat of the manual processing. We're going to be using Amazon Bedrock Agent Core that's going to be orchestrated for all our agents. And the agents themselves, they can use the most sophisticated models that are available not only in Bedrock, but also from other cloud providers or other partners. So, providers such as Anthropic, even our own Amazon Nova models. And these, in general, provide a lot more flexibility and higher accuracy than traditional OCR. Now, with just this approach alone, we've now automated what used to take maybe a team of people hours to days, and that's something that can be done in just a couple of seconds or minutes. Now, let's make all of this accessible to our human users. Now, this is where we are going to be leveraging Transfer Family's Web UI or Web Apps service. This is especially for your end users because you don't have to know SFTP commands, right? It offers a simple browser-based access. It is completely self-served and has security built-ins, which means that you can have rules-based access, right people have access to the right files and at the right time, built on the principles of zero trust. Now, we're going to be deploying all of this using Terraform. The Transfer Family service team, and in fact, it's endorsed by our solution architects because we built this, we support an official module that is available in the Terraform registry. By the way, anybody using these Terraform modules from Transfer Family? You are? Oh, great, awesome. Anybody using Terraform in general to automate? Perfect, beautiful.
Great.
Awesome. So you're going to really enjoy what we have for you today. And for those who are not using our modules, this is, I strongly encourage you to use our modules. That's perfect. Using modules basically allows you to improve standardization. You can deploy all of your infrastructure across your environments in a standardized way. And you ideally want to track everything in Git, right? So for tracking of changes, for rollbacks, and auditing. And lastly, we recommend that you deploy everything using a CI/CD pipeline. All right, now it's time to build. Now we're going to go start getting into the code. And if you want to see the actual code yourself, please grab the QR code. It will take you to the GitHub repository that we have for you and also the specific branch that we're going to be working off of. We'll share the QR code again in the end. So for those who have missed it, that's perfectly OK. We're going to be showing this a couple of times, actually.
Yep.
All right. I'll just give everybody maybe 10 seconds. I see some people are still grabbing the code. All right. So I think, Matt, you have some stuff to show them, right?
I do, yeah.
Yeah. Why don't you take it away?
Before we get into the first part of the code here, I'm going to show you what we're going to be building. And you may have caught it. Prabir was showing the various stages of our architecture, stage 1 through 4. And that's actually how we're going to be building out our architecture today into various stages. So the first stage is to create our AWS Transfer Family server. And so we'll be using the Terraform modules for that. But we also need to incorporate authentication. And so that is where we're going to be deploying the Transfer Family Custom Identity Provider solution. And I'll talk a little bit more on that when we get into the code itself. But it's essentially a solution that is endorsed by the Transfer Family service team for integrating the most popular identity providers. And we have a pre-built Terraform module for this as well that I will show you. So with that, I'm going to go ahead and get into the code. And Prabir, if you could switch me over.
There you go.
And we are now in the terminal here. And so very briefly, and again, you'll be able to see this if you go to the code in GitHub after the session. We've structured our Terraform into various stages here. And we have a couple of additional modules that we put into this solution. And so the first stage is our Transfer Family server stage here. We did also deploy a couple of prerequisites, IAM Identity Center, Cognito User Pool. That's in stage 0, but we've already deployed that. So before I go into the code, I'm going to go ahead and start the deployment. And we have several scripts to just help us with getting the deployment going. And we will do stage 1 deploy.sh. And this is just quickly showing what we're actually deploying here. So we have Terraform apply, and then we're using a variables file. And I'll show you that variables file briefly here. We've actually broken up the solution into different stages with feature flags in our Terraform. And that's really how we're controlling what we deploy and when throughout this. Obviously, in most environments, you would not need a stage like this, but we're doing it for the purpose of the code talk. So let's kick off the deployment. And while that builds, I will jump over to stage 1, our transfer server. So a couple key callouts here. The first thing that we are actually building, and I'm going to bring this down to give us some space, is our custom identity provider solution. And so for that, we're using the Terraform for AWS Transfer Family custom IDP module that is already available in the GitHub repository. So this really simplifies the deployment of the custom IDP solution itself, which consists of a Lambda function with authentication logic and modules for various identity providers, and then DynamoDB tables that are used for configuration. And then for some identity providers, they can't be reached over public internet, and you may need to attach them to a VPC. And so in order to do that, you can modify this use VPC parameter, set that to true, and you can specify the subnets and the security groups that you need to attach the Lambda function to so that it can communicate with your identity provider. There's several other optional features. For example, you can put an API gateway API in front of the Lambda function. If, for example, you want to attach a web application firewall for additional security. But this is really all you need out of the box for this custom IDP solution to be deployed with Terraform. Now, the second thing we need to do once we've deployed the custom IDP solution is we need to create our transfer family server. And again, we're going to use the transfer family Terraform module for that. And in order to configure the transfer family server, we have a couple of parameters here. The first one is our domain. So we'll configure either S3 or EFS for the storage. In this case, we're going to be using S3. And then we have options for the endpoint type and the protocol. So we're going to set this to a public endpoint, but you could also attach this to a VPC, for example, if you wanted to run a private SFTP server. And then for a protocol, we're going to be using SFTP protocol. Now, for configuring authentication itself, we need to change the identity provider parameter to AWS Lambda instead of service managed. And then we need to specify the ARN of our custom IDP Lambda, which is one of the outputs from the module. And so that's what we've done here. And you can see now this will wire up authentication to forward all authentication requests to our Lambda function.
Hey, Matt, before you go further, so this is cool, but I want to understand, like, how do you manage users and how do you map them to these identity providers?
Yeah, that's a great question, Prabir. And actually, all of this is done via configuration in DynamoDB tables. And so there's a couple of ways for you to configure those DynamoDB records. Terraform is one option, but you could do it externally as well. And the solution has really two tables. One is for the identity provider configuration, and that's what this DynamoDB table item record in Terraform represents. We give our provider a name. In this case, it's Cognito pool because our repair shops are going to authenticate via an existing Cognito user pool. And then we specify the configuration. And in the Cognito configuration, we need to specify an app client ID for our user pool and then the region that the user pool resides in. Then when it comes to the user, we can create records for each individual user. And in this record, we have our user. In this case, it's actually the any company repairs user, but we're using a variable to specify the username. And then you link your users to the identity provider that you've created in your identity providers table. So in this case, the Cognito pool provider. From there, you specify what access and entitlements you're going to give for that transfer family session. So transfer family supports this concept of logical directories or virtual directories where you can map any path on the SFTP server to an S3 bucket or an EFS volume. In this case, I'm mapping the root folder to a bucket that we have provisioned where our claims that we're uploading are going to land initially. So our deployment looks like it is complete, and I've got some output here. We can see our transfer family server endpoint, and I have a test script just to make sure that everything is functioning as expected. So we're going to go ahead and test out this code quick that we've deployed. And we'll do stage1-test.sh. So what we're going to do quickly is retrieve credentials that we stored in Secrets Manager, and we're going to use those to authenticate to the transfer family session. And you can see our SFTP session is going to use any company-repairs as the user. So let's go ahead and kick that off. Say yes to the fingerprint. And I'll enter my password. Now, when I enter my password, if it's successful, we'll immediately upload one of our claims files just as a test. And it looks like We were able to upload that file successfully, so that's a good sign. The last thing we're going to do, just to make sure everything is working as expected, is verify that that file is indeed in the S3 bucket where we expect it to be. And simple S3 we can see claim1.zip was uploaded, and we are all set. So in this stage, we just quickly built a transfer family server. We integrated the custom IDP solution, and we integrated our Cognito users for authentication. And so with that, Prabir, I think our next step is to implement some malware scanning. Is that right?
Yeah, that's right. Quiz time. Do you remember which service we intended to use for malware protection? GuardDuty. There you go. Somebody's paying attention. Perfect. So for anybody using GuardDuty for malware scanning today? All right, see, I see a few people over there. So if you're using GuardDuty for malware scanning, so the way the GuardDuty works is that it scans every object that lands into a protected S3 bucket. And the way it does it, that it adds an object tag based on the scan results. So if it's a clean object, it'll add a clean tag. If it's a malicious object, it'll add a no threats found tag. What we've done with this is that we've expanded this architecture to leverage event-driven approach. So we have Event Bridge that is listening to GuardDuty events, and the scan results are being passed on Event Bridge to an SQS queue. Now, we've added SQS queue just as a matter of decoupling and best practice so that we can scale and offer resiliency. But also, like if our downstream processing is unavailable, we can always replay these messages using SQS. Now, SQS further triggers our Lambda function. So our Lambda function is basically reading off all the events in our SQS queue and processing them. Lambda over here is kind of the brain or the logic that decides, based on the scan results, which files to be routed to which bucket. So once again, clean files will go to a clean bucket, malicious file will go to a quarantine bucket, and any object that is not treated, is not processed, will go to our error bucket. Optionally, in this module, we've also added a dead letter queue in SQS, so any messages in the queue that are not processed, we want to actually store them too because we want to investigate what happened and process them at a later stage. And we've also added the ability to send notifications through SNS. We believe this is actually very important because if you have a malware in one of your accounts or your buckets, you want to get notified immediately. So this is an optional feature, and we'll be showing that in the code right away. Matt, do you mind switching to the demo screen?
Happy to.
Awesome. So before I show you the code, I'm just going to kick off the deployment. So again, I'm using these beautiful scripts that Matt put together. And once again, it's very simply, it's just doing a Terraform apply. It's not the screen from the matrix. It's definitely doing a Terraform apply if you've already seen that. All right, so the Terraform module for malware protection is actually pretty simple. So you can see it is available as a submodule in our Transfer Family malware protection, Transfer Family server module. And it requires primarily 3 different things. Number one, you have to specify a source bucket or a bucket that needs protection, right? So in this case, it's defined using our S3 ingest bucket block. I am actually referencing a bucket that was created in one of our previous stages. And it's the same bucket that Matt sent and created an SFTP file to. The second part of the configuration is our optional features. So this is where we can specify an SNS topic for malware detection, and optionally a dead letter queue. So all those configurations, we've kept them as true, as best practices default, just to show that this works out of the box. The main thing you want to know is that we have a routing config. So the routing config maps GuardDuty events. So these are the exact same events. Some of you said that you use GuardDuty. These are the exact same events that GuardDuty emits. So for example, if the file was clean, GuardDuty will put a no threats found tag to one of our buckets. And you see that this is being mapped to a clean bucket. This could be any of the buckets that you've created from maybe if you have another module that you use to create S3 buckets, so you can refer them as well. For any object that was considered malicious, we'll have a threats found tag, which will move to our quarantine bucket. And any objects that were not processed by GuardDuty, maybe there was a permission issue, maybe the object type was not supported, was an access denied or failed, they will automatically move to our errors bucket for further processing.
And Prabir, I just want to make sure that I understand this correctly. This isn't tied specifically to the transfer family service. Like you could use this for really any solution where you need malware scanning in S3, right?
Yeah, that's right. So the way we build these modules, they're really independent building blocks or Lego pieces. You can take this module, let's say you already have a pipeline that deploys all of the above, right? VPCs, transfer family servers, maybe identity provider, maybe you're managing it separately using CloudFormation, that's absolutely fine. But you want to add malware protection, you can just take this module and deploy it in any of your Terraform pipelines. So this will work out of the box. And that's in fact how we build all the other modules too. So you don't have to use everything or everything in the example to have a full feature deployment. You can really plug and play. Yep.
That's awesome.
Great, thank you. So let's test our malware protection. Oh, I don't want to add anything on the code, so let me go backtrack. All right, stage 2 test. So once again, we're using some helper scripts that are just simulating the same kind of flow. The first thing we're going to do is that we're going to connect to our SFTP server. So I'm going to start the SFTP session. I'm going to enter my password for the SFTP server. Now I see that my claim 1 file was updated. At the same time, I also added an iCar file. Does anybody know what an iCar file is? Perfect. So an iCar file is a way for you to test malware protection without compromising the system. You actually don't want to inject an actual malware to test if your malware protection is working. You know, that's not a good idea. What if your system gets infected? So iCar files are a great way to test malware protection. So in this case, we are parsing CloudWatch logs, and we see that GuardDuty did pick these up as appropriately. So our clean file was tagged as no threats found, and our malicious file, which is our iCar file, was detected as threats found. Now I'm just going to do an S3LS on our clean bucket to see if the files did land in the right place or not. So firstly, if I see in my cleans bucket, that was over here. So I did see that my file was processed properly. My clean file landed in my S3 clean bucket. If I look at my quarantine bucket, I do see that my iCar file was successfully moved to our quarantine bucket. And again, all done through event-driven architecture. I didn't have to make any manual changes on my side. All right. Now, I think it's a good moment for us to talk about agents or Agentic AI. How many of you are using agents or AI-based agents or exploring with AI agents today, whether it's in test? Okay, a few of you. So for those who are not using AI agents, this architecture actually might look very familiar. You know, let's say if you have some kind of file processing pipeline that uses intelligence, what I mean by intelligence is it uses some of our AI services. There were just a lot more steps involved in building something that does, I would say, file processing. And these steps were basically Lambda functions or step functions that basically would call different AWS services. The thing I want to call out that this architecture is still very relevant. So if you have a very, I would say, a pipeline that's very, very strict in terms of you know exactly what needs to be processed and what orders. This is perfect. This scales really well. But for organizations that are looking at a little more flexibility, this is where agents are really, really powerful. Now, for this use case, we're going to be using an Agentic AI workflow, and we're going to be orchestrating all our agents using Amazon Bedrock Agent Core. We built all these agents using the Strands SDK, which is an open source framework that AWS developed for you to build agents and offers a lot more flexibility. And I'm going to talk about it just in a second. We have a couple of different agents. I'm going to talk about the agents that are in the middle. So I have an entity detection agent. What it's doing is that its job is to extract text from a PDF file. I have a validation agent that actually is built around the principles of multimodality. So it will take text and will also read the image and then compare if the text matches with the image or not. I have built a summarization agent that summarizes all the findings from the previous agents. And I have a database agent that basically takes all the entities that are detected and pushes them to a DynamoDB table. The brain behind all of this is our supervisor agent, which is coordinating all the tasks between the other sub-agents. So the supervisor agent kind of decides which agent to invoke at what time. Now, the thing I want to mention is that this pattern is actually not only relevant for insurance customer, but it can be applied to any industries. right? Somebody mentioned healthcare, like maybe if you're in, maybe in finance, this kind of flow and this kind of architecture works really, really well. It's just that you have to change the prompt a little bit. And speaking of prompts, let me actually show you how I've built these agents very quickly in terms of the prompts. So we have our claim files. The first thing I'm doing is that I've actually tasked the entity detection agent, and I'm using simple natural language to build my prompt. I'm asking it to extract this information from this card damage claim and ingest it in a JSON format. I'm asking my validation agent to analyze this card damage image against the reported claim details. I'm asking my summarization agent to summarize all of the findings into this specific format that I'm showing you over here. And lastly, I have my database agent, and I've instructed it in natural language to extract all these entities and push them into a DynamoDB table. All right, so let's talk about how I've built this in code. Matt, do you mind switching to the demo, please?
Sure. There we go.
Awesome. So the first thing I'm going to do is kick off the deployment. Now, I want to quickly walk you through the architecture and how we've built these modules. So the first thing I want to mention is that we are using one of our modules for Agent Core. This is a module that AWS supports out of the box. It's supported officially. So we're using one of them. But the thing I want to show you is actually how I build these agents using strands. Anybody using strands, by the way, today, or have played around with strands? Okay.
We got one.
We got one? Okay, perfect. I didn't see. Great. Awesome. So for those who have used strands, or this might look very familiar, but for those who haven't used strands, strands actually works on 3 different concepts or 3 different things that it requires. So the first thing that strands require is that the agent needs to have a model, right? So the model is basically the brain for the AI. The second thing that the agent needs is a tool. Now, a tool, in very simple terms, is an action that you provide to the agent and an action that the AI agent can perform. This action could be a function, right? Something that you specify or that you do a task. Or it could be another sub-agent, right, that this orchestrator agent can use. So it's basically you're giving the AI hands to interact with the outside world. Now, I've built a couple of tools for my orchestrator agent. I'm going to show you an example of one of them. The tool that I've built over here is actually a very simple function that calls one of our sub-agents, which is the entity extraction agent. And for those who are familiar with programming, what I'm doing is pretty simple. The first thing I'm actually asking is to extract the ARN of my entity detection agent. In my step 2, I'm actually ingesting a payload, which is my bucket name and my object name, or the PDF key, right, which is going to be our claims forms that we'll be testing. I'm creating a unique session ID, and again, I've done this just for best practices. I want to troubleshoot every session in CloudWatch. And in step 4, this is the place where I'm invoking the entity extraction agent in Bedrock. And lastly, in my final step, I'm just parsing all the outputs that have been generated from this agent, and then this orchestrator agent can read them and proceed to the next step. Now, I've built the other agents in a similar way. So you see that I have the fraud detection agent specification. I have the database insertion agents. It's basically just calling these agents. But the thing I want to show you over here is this. Now, for those who have interacted with some kind of text-based or LLM-based service, even ChatGPT, this might actually look very familiar. So instead of using complex logic, right, statements written in SQL or whatnot, right, I am instructing this agent in natural language to do the following, right? So I've given it a task. I've said that you are a claims processing workflow agent leveraging strands. I'm saying that your job is to extract entities, validate the damage consistency, insert all this data into a database, and generate a summary. Now, the agent decides, based on this task I've given, which tools to use. And you saw, I showed one of the tools the way I've configured it. So the agent decides, you know what, okay, I need to extract entities. I know that I have a tool for that, which is my sub-agent, so I can call that. So that's how we've built this in strands. And again, a fun fact is that I've built this in a couple of minutes. So we were using Kiro CLI, so for those who are using Kiro or any other AI-powered coding assistant, this can be done very, very quickly. So all you have to do is just put your business logic, ask it to build something in strands, and you will have your Agentic AI workflow. All right. Now, before I test the agents, I'm going to show you what the claim files look like. So I have two sample claim files. On my left, I have a claims record that shows, let me come here actually. A car that was damaged in a parking lot. We have a rear bumper damage that happened in a parking lot, and the estimated cost to repair it is $995, if I'm not mistaken. And if you look at the image, this is very consistent with what we see. But on my right-hand side, I have a claim form that states that this was actually a minor front bumper scratch that happened in a grocery store parking lot. And I don't know, like, do you think that this is a minor scratch?
Doesn't look like a minor scratch to me.
I know.
Yeah, I would say that's a little more than a minor scratch in a parking lot.
Yeah. And by the way, no cars were harmed in making this demo, right? So I just want to call that out. This would have been a very, very expensive demo otherwise. Awesome. So let's test this, Matt. What do you think?
Yeah, let's try it out. I'm going to switch back to the demo.
All right. So once again, we are using a test script. Same flow, our event-driven architecture is going to kick in. We're going to log into our SFTP server. We're going to enter a password. And we've uploaded one of our claim files. And one thing we've did with the script is that we've asked it to parse CloudWatch logs. So we have like 5 different agents. We thought that the best use of our time wouldn't have been to go into the AWS console, find CloudWatch logs. Who likes going to the console, by the way? Anybody? You guys are all like.
Ouch, no one likes. I like the console.
The console is cool. Yeah.
Let's not be too mean.
So everybody likes to like code being like the IDE. Yeah, that's what I see the team over here. Yeah, cool.
I guess that's the right answer.
Perfect. Cool. Maybe. I don't know. All right, so we see that our CloudWatch logs picked up different things that are happening in our workflow. So we see the first thing we found that, I'm just going to scroll up just in a bit. We see our entity detection agent picked up all these entities, right? Our fraud validation agent, again, took this data and it's now reading the image that I've supplied with it. Our workflow agent is our orchestrator, so it's kind of showing the different orchestration that's going on. And our database agent, again, took all these entities, and now it's meaningfully parsing it and ingesting into a DynamoDB record. All right. So I see that our claims processing was finished, and I'm going to show you the claim in just in a minute. All right. So I see that my claim was successfully processed, and I'm going to move on to the second claim as well. I'm going to test both of them, and we're going to see them at the same time. Okay, so I have uploaded this file. I know for those who like the console, let's actually go into the console and see what's happening. Okay, so we've created a couple of different buckets. I will be in my clean bucket because all these files were clean. And I can see that my claim was successfully uploaded. I just uploaded my claim 2, so it's still being processed. But at the same time, I have these 2 prefixes. So I have my submitted claims. I see the claim 1 that was submitted. So this is very consistent with the image and the PDF that I showed to you. And our process claim was the one that was just processed by the AI agent. Sorry, I'm the same prefix again. No, so if I open this summary, let me just make it slightly bigger. So this claim is claim 1. We saw that this was a claim that had, that said that had a minor rear bumper damage. The estimated cost to repair this claim was $995. And this is what my summarization agent, by the way, did. So it states that our fraud agent said that the fraud agent is 90% confident that the description matches the image. The analysis, again, all done in natural language, which says that this is a car that had a minor bumper damage. It's very consistent with the claim description. There's a visible denting on the rear bumper, and there's no apparent damage on the vehicle. And the recommendation by this agent to our human agents is that this claim can be approved. So again, this is super, super powerful. Just eliminated a whole bunch of manual steps that human users had to do. Now, at the same time, let's
see the second one.
Yeah, let's see. I'm curious about that. Let's see if it processed. Okay, so my second claim is also processed. I think should be the first one over here. All right. Yes, legible. Okay, perfect.
Yep.
So my second claim, again, our claim forms stated that this was a minor front bumper scratch, and the estimated cost to repair that was $350. But our AI agent said that this is actually, the image does not match the description, and the agent is 95% confident, so even more confident in that this is not a scratch, right? So that's exactly what it states. It says that although the claim suggests that this is a front bumper scratch, but the image shows severe front-end damage, and it suggests that this claim should be reviewed by a human just to be sure. So the thing I want to call out is this shows how powerful this workflow can be and how you can apply this in your use cases. And I built this using simple natural language prompts. The power of this is that you can literally take our demo, maybe play around with the prompts, and have something up and running for your own use cases too. The one thing I do want to call out is that I don't think that our business users will like going to the IDE. I know all of us do like the IDE, right?
Or the AWS console, maybe.
Yeah, not even
be a
that.
little too advanced for someone that needs to review insurance claims, right?
So what do you think, Matt, we should do for that?
Well, I think this would be a good time to implement Transfer Family web apps.
Okay, take it away then.
So why don't we do that? And I'm going to grab this, switch back to our PowerPoint. So the last stage, now that we've created this awesome workflow where we're automating the file or the claims processing and summarizing it, looking for the potential for fraud, is we need to make this available to the humans that are going to do this final review and sign off on these claims, right? And so we'll call those our claims reviewers, and we're going to give them access using a Transfer Family web app. So show of hands, is anybody using Transfer Family web apps at all or explored it? Awesome. And so anybody here use a service called S3 Access Grants? Yes, obviously, if you use web apps, you use S3 Access Grants. Good answer. So we're going to be using a combination of these services today. I'm going to briefly, for those not familiar, walk through how this service works. So when you deploy a web app, you integrate it with another AWS service called IAM Identity Center. And Identity Center supports federated authentication from identity providers, Okta, Entra, just to name a few, but really any SAML-based identity provider can integrate with Identity Center. And that's how your end users will authenticate. They'll authenticate through Identity Center and then be redirected back to the web app. But then we need to assign them permissions and authorizations. And that is done through another service called S3 Access Grants. And in order to do this, we first define an S3 bucket location with our access grants. And so this is where we're going to specify a location to assign grants or permissions to. And then we're going to assign individual grants for our users or groups. And in the table in the lower left, that's the grants that we'll be assigning. And you can see that our claims reviewers group will be given read-only access to the submitted claims and processed claims buckets. And then we'll have a claims admin group. If they need to manage the files in the bucket, we'll give them read and write access. So we're going to set all of this up. Now, the one thing I want you to be aware of is if you've ever had to configure all of this in the console, especially the access grants and setting up and assigning the permissions, you may find that it's a lot of clicks. It's a lot of manual processes, looking up user IDs based on their display names. So we're going to automate all of that with Terraform here in just a moment. So let's switch over, Prabir. Mm-hmm. And again, I'm going to go ahead and kick off our deployment before we show the code. And we'll lower this. Okay, so what we're going to do today is show you what we're calling the alpha module of the Transfer Family web app for Terraform. And this is something that we haven't released yet, but it is in the source code that we're sharing a link with today. And it's something that we're hoping to release here very shortly. But what we expect this will allow you to do is really simplify deploying Transfer Family web apps and configuring your S3 access grants for your user entitlements. This is made up of one main module for the web app and then two submodules, which I'm going to walk through here quickly. So first, we use our Transfer web app module itself. And this is what's going to actually deploy the Transfer Family web app. And a web app is actually really easy to deploy. It's fully managed. With a couple clicks in the console, you can deploy a web app in the Transfer Family console. And really all we need to do is specify the name that we want to assign our web app. And then we need to connect it with an IAM Identity Center instance and an S3 Access Grant instance. And usually these are both in the same AWS account. However, if you already have an organization-wide Identity Center instance, you can use that instead of an account-based instance. So in a couple lines of code, we have our web app deployed. Now we need to configure our permissions. And we have a submodule first that will define the S3 locations where we're going to be giving users access in web apps. So what this module is doing is configuring this in the S3 Access Grants instance. And it's automatically creating an IAM role with the associated permissions and trust policy required. And it can optionally create a bucket for us if we want to specify a clean bucket that we're going to be using. Or in this case, we're going to be using an existing bucket which has those processed claims. The other thing that it can do, and this is a requirement when you're configuring Transfer Family web apps, is we're going to set the CORS configuration on our S3 bucket. So you need to do this for any S3 bucket that you configure with web apps. And so this will also do that for you automatically as well. Now the last piece is to configure the entitlements or the permissions themselves. And that's where this web app users and groups module comes in. And again, this is a submodule that will be under the Transfer Web Apps module because it's purpose-built for web apps. And we can define both user and group entitlements via the users and groups parameters. In this case, we're doing role-based access control, so we're assigning groups. And first, we specify the display name for our group. Now, I'll show you in the console in a moment. What this actually does is it looks up the group ID, which is a UUID of that group in Identity Center, and it retrieves that and will use that for the configuration. So it's simplifying a lot of that process of doing lookups. And then we assign our actual access grants. In other words, the permissions that we are going to give to this group. In this case, for our claims admins, we're going to assign read-write access to our S3 bucket location that we defined in the previous step. And we're going to give it access to the entire bucket, so all paths with that wildcard. Now for our claims reviewers, very similar setup, except we're going to have 2 access grants assigned. First, we're going to give read access to submitted claims and any sub-files and folders, and then to process claims as well. So let's check on the status of our deployment. And it looks like we deployed successfully. So there's nothing to test in the terminal this time. I'm going to take you to the actual console because this is a human interface. Quickly, what I want to show you is what we just created. So this is our Transfer Family web app that was just provisioned. If we go into our web app, we can see the configuration, including our Identity Center instance being configured. And if we go to the Groups tab, we can see that both of our groups have been assigned. These are the group IDs that I talked about. So these are just UIDs that are unique that you would otherwise have to look up manually yourself. So we've really simplified that process with this module. And now I'll jump over to S3 Access Grants. Actually, I'll just switch over to this tab. And if we go into the details here, we can see we have our location set up, in this case, our claims bucket with our clean and processed claims. And then our grants, so you can see our grant IDs for our claims reviewer and claims admin groups, and the grant scopes and permissions that have been applied. So all of that was done with just a couple of lines of Terraform code. So what does it actually look like once you authenticate? Let's go back to web apps, and we will open up our web apps URL. We'll sign in as our claims reviewer here, and I'm going to make this, I'm not going to turn up the volume, I'm going to make this just a little bit larger, maybe too large, but we'll see. I'm going to remember my password, hopefully. All right, so now we're in our user-friendly Transfer web app interface. And if we look here, we have access to both the processed and submitted claims, read permission. If we go into our process claims, we can open one of our claims folders and download that same summary that Prabir showed us earlier. One other thing to call out here is there is some level of customization you can do with these web apps. So if you need a custom logo or you want to use your organization's logo, you can specify that in the configuration, and that will show up here instead of the transfer web app icon that's right here. And this also is a little small, so I'll make that slightly larger now that we've already gone through it. All right, so that, I think, is the end of our architecture. And just to quickly recap what we've done today, so we configured a transfer family server with authentication to an external identity provider. In this case, it was Cognito. We did malware scanning automatically once we received files. We then used Agentic AI to process our submitted claims, look and see if there was an inaccuracy issue. And then we made those claims, once processed, available to our claims reviewers. So with that, Prabir, where do we go from here? What are our next steps?
For sure. So I just want to say before we wrap up, all the code that you saw today is powered by our Transfer Family Terraform module. And this is available to you for it to use whenever you can. And the step-by-step example that we covered today is one of many examples that exist in our repository. So it's built typically around use cases. So if you have a specific use case, we showed you different components such as connectors. But today we showed you a use case with Agentic AI. All of these can be deployed in just a couple of minutes. So again, very, very quickly for you to set up, especially if you're using infrastructure as code. We launched this module only just a couple of months ago, and we've already had over 10,000 downloads. And I just want to thank all the AWS solution architects that are basically contributing to this, but also folks like you. We've had a lot of external contributions too. So if you're one of them, thank you so much. You can grab this QR code for direct access. This will take you to the root of the module, which has all the examples and has all the modules that you can use in your workflows. One thing I want to call out is that we do maintain a public roadmap for all the things that we're working on. So if you like any of the features that we're working on, you can always do a +1 on them. But if you feel that there's something that we do not support, or if you have any suggestions, you can always create a GitHub issue. My team and I, we review these almost daily. We want to get new features for you as soon as possible. And I'm super excited to see what you will build next with these tools. So with that, I just want to thank you for your time, and I hope you enjoy the rest of re:Invent. Thank you.
Have a great week, everyone.